The amount we know about our solar system is amazing, especially if you stop to consider that we've barely left our planet. Stuck here on Earth, all we know about the universe around us comes from the limited amount that we can see. It's as if we've tried to map the city of Chicago just by drawing what we can see outside of our window, barely able to lean out onto a patio. But what exactly is our solar system, and how is it formed? Our solar system is made up of 4 rocky inner planets, Mercury, Venus, Earth, and Mars, 4 outer gaseous planets, Jupiter, Saturn, Uranus, and Neptune, and clusters of both rock, such as the asteroids belt, and ice, the Kuiper belt objects, and the Oort cloud. The variety is amazing. Moons of all types and compositions, different paths and orbits, sizes, even different sounds, such as the rings of Saturn. But how did all of this form? It started 4.6 billion years ago, an incomprehensible amount of time to a person, but that's less than 1/3 the total age of the universe. At that point, this whole region, this whole place we live, was just a cloud of dust. Most of this dust was left over from the Big Bang, hydrogen and lithium hanging around the vastness of space for 10 billion years or so. But the rest was the body of a massive star, or several massive stars, who long ago blew itself apart, sending pieces of itself across the galaxy. All the material in the solar system that's not hydrogen is just leftovers of the star. Everything made up is leftovers of the star, including you. At the time, the dust and gas was stable, drifting and forming in a nebula, the same that you can see in some of the Hubble's most famous pictures. Then one day, everything changed. A massive star, 10 to 100 times bigger than our sun, exploded, blew right up. The shock wave caused some of this material to get a little closer to each other, and then gravity took over. As more and more material was pulled in, gravity became stronger, pulling in even more. And as everything got closer, it also became hotter, and, think of it like a dance hall where you've got too many people inside. People can't really move, the body heat builds up, and just everything becomes uncomfortable. And that was basically what our sun was like at the time, called a protostar. So our sun, now just a brand new protostar, is just a ball of gas. Gas too close together, couldn't get away. Slowly, bit by bit, more gas is added, bringing more mass, meaning more is attracted, and the more mass there was, the more pressure built up. Now remember, hydrogen atoms are positive, they want to move away from each other. But when that pressure gets too big, they can't avoid each other. They smash into each other, and that's when you get fusion. Hydrogen turning into oxygen and helium and all these other kind of crazy things. And a star is born. Meanwhile, everything's coming closer together. Everything's getting pulled towards the sun. And just like the figure skater who pulls in her arms and spins faster, the cloud of gas around that star, which will become our sun, begins to do the same. As it gets faster, it stretches out, it thins out. Now, not all that debris will fall into the sun. Some is now moving fast enough that the pull of gravity can just keep it into orbit. Can't really pull it all the way in. But the region, it's not stable. The gas can't move in closer to the sun, but that's not meaning that the things around it aren't getting a little too close for comfort. This debris spends millions of years colliding into each other. And these, what are called protoplanets, do the same thing as the sun. As they get more mass, they pull in more around it. And as these collisions happen, it's like smacking two things together. They start to get hot. So close to the sun, gas and what are called volatile liquids, things like water, tend to get blown away, evaporate, dissolve. So only metals and rocks can survive. So you tend to get the terrestrial planets. While further out, the gas tends to remain stable. It's cooler, less volatile, and so you get the gas giants are born, further out, orbiting more slowly, more sedately. At this point, the sun is formed, and it will remain fairly unchanged for the next 10 billion years or so. The planets are all mostly formed, although most, like the Earth, are just a giant blob of liquid and rock and metal cooling for millions of years. Yet as they cool, profound changes take place. Rocks releasing gas, atmosphere forming, water falling from the sky, until finally a place exists that you can call home.